Hello friends, welcome to this section. In this video we shall be checking for unit consistency, and I shall be making reference to two examples from the derived quantities. So we shall be using two quantities from the derived quantities. One is force and the second we shall be considering pressure P. Now, using the first one, we want to check for unit consistency. Force we know is measured having units in Newton, while pressure is in Newton per square meter. Newton per meter, pressure force over area. Pressure force over area. So it's having units in Newton per square meter, Newton per meter square, or written in this form, Newton meter minus 2. Now, how do we check for consistency for each of these? Now, let's pick force. The first one, force. Force is a derived quantity having the formula mass times acceleration. That is for force. Let's pick the first one, the mass. Remember, the mass is obtained from the fundamental quantity. So mass is having m. Acceleration can be broken down. Acceleration is simply velocity, change in displacement over time. That is velocity over time. Now, from velocity, we can get something out of it. Velocity is displacement over time. That's distance over time. So we have velocity to be meter per second. So we have displacement, or let's use the symbol displacement, which is L from our fundamental quantity. So L over T, that is for velocity. Velocity is displacement over time. That is for velocity. We still have time all over T. So this T is for this time, while the velocity is L over T. At the end of the day, we have something like this. L over T square. As this T comes down, basic mathematics, where we have L divided by T divided by T, which automatically means L over T times 1 over T, which makes L over T square. Another way of writing this is written L T minus 2. So this is for acceleration. Remember, for mass, we had it as m. So at the end of the day, consider force. Checking for unit consistency, it means force F will be equal to mass, which is m, times acceleration. And acceleration, we have obtained it as what? L T minus 2, which in most cases we can still take it as m L over T square. So this is how we write force in terms of dimensional analysis, where m represents the mass, L T raised to power minus 2 represents acceleration. So this is for force. In the second case, we consider pressure. For pressure, we have pressure to be force divided by the area. The pressure of a substance, pressure of a body is the force exerted by the body and the area it occupies. So force over area is given as pressure. Now we have done previously for force, but let's still break it down. For force, we had force to be equal to mLT minus 2. For area, we would have area is length times length twice. So area is L raised to power 2, L times L, which is L squared. So at the end of the day, when we combine both of them together, we are going to get the unit consistency, the dimensional analysis for the pressure. So how is it done? For pressure will be equal to the force, which is this mL over T square, which is for this or this, times, divided by the area over the area. So if I'm using this division, area is L square, which automatically means mL over T square times 1 over L square. Division changes to multiplication so that one of the L can cancel one of the L here. At the end of the day, we have a pressure to have units in M over L T square, which can be written as M L inverse T raised to power minus 2. This is how to write the dimension analysis for pressure. These are done with respect to many more derived quantities. This is just for force and for pressure. I'm sure we got value from this video. Please feel free to drop your comments in the comment section, and also like, subscribe and share my videos for more persons to see.